All right, welcome to Next Gen Manufacturing Nexus. Today, we are diving into the world of aerospace manufacturing, where the stakes are, well, astronomical. Literally, we're building machines that defy gravity, and getting it even slightly wrong just isn't an option. So let's get into how digital tech is completely reinventing the future of flight.
I mean, just look at this. This isn't just a machine, it's a genuine marvel of engineering. But here's the thing. To create the next generation of aircraft, with parts that are lighter, stronger, and more ridiculously complex than ever before, we have to solve some monumental challenges. We're talking about pushing the absolute limits of what's possible.
So that's the big question, isn't it? How in the world do you manufacture perfection when you're under all this pressure? Well, it turns out the answer isn't just about bigger, more powerful machines, it's about smarter ones.
To really get the solution, you first have to appreciate the problem. Down on the factory floor, engineers are fighting a daily battle against the laws of physics. Let's break down who they're up against. First up, thin walls. See, aerospace parts have to be crazy lightweight to save fuel, but also incredibly strong to handle immense stress. Trying to machine a part that's paper thin in some places without it warping or just breaking, that's a constant struggle.
Then you've got these insane shapes, these complex geometries. Just think about a turbine blade in the jet engine. It's basically a metal sculpture, and every single curve is designed to control airflow with absolute perfect precision. Carving that out of a solid block of metal is an incredibly intricate dance.
And then there's the big one, the ever-present enemy, vibration. Even the tiniest chatter from a cutting tool can wreck the whole part. Or worse, it can cause microscopic cracks that could lead to a catastrophic failure later. It's a constant threat that can destroy a part worth thousands of dollars in a split second.
And this quote just nails the business reality of it all. Engineers are caught in this pressure cooker: make it perfect, make it fast, and make it cheap. For decades, the rule has been you can only pick two.
But now, things are different. Engineers have a new arsenal, a digital toolkit that is completely changing the rules of the game. This is where intelligent manufacturing, the revolution we call Industry 4.0, enters the picture.
So what the heck is Industry 4.0? Well, in short, it's the smart factory. It's about taking machines that used to be isolated and connecting them into one big, intelligent, data-driven network that can actually think, predict, and adapt all on its own.
And this is basically how it all works. You start with IoT sensors all over the machines, collecting a constant stream of real-time data. All that data is then analyzed to find patterns that a human could never, ever spot. Then, AI uses those insights to optimize the whole process on the fly, and the cloud connects everything, giving engineers a bird's-eye view from anywhere in the world.
This new toolkit makes three massive breakthroughs possible. You can monitor those destructive vibrations in real time. You can predict when a tool is about to fail and replace it before it breaks something. And get this, the machine can even adapt and correct its own errors automatically. It is a complete game changer.
But maybe the most powerful tool in this entire new kit is the ability to build and test everything in a virtual world before a single piece of metal is ever cut. So, welcome to the virtual factory.
At the very heart of this is something called the digital twin. And it's exactly what it sounds like. A perfect one-to-one virtual copy of the physical machine sitting on the factory floor. Now, this isn't just some 3D model. No, this is a living simulation that understands the machine's physics, its limits, and exactly how it behaves.
This is where the magic happens. In this virtual space, an engineer can run the entire machining process, simulating every single line of code. They can see precisely how the tool is going to move, how the material will react, and spot any potential collisions or errors long before they become expensive problems.
The benefits here are just enormous. You can forget about expensive trial and error on the real machine. No more scrapped parts that are worth tens of thousands of dollars. You get it right the first time, every single time, in the digital world.
Okay, so all this theory sounds great, but does it actually work out in the real world? Absolutely. The data's in and the numbers are staggering. Let's look at the impact.
By getting it right in the virtual world first, material waste from scrapped parts was cut by nearly half. That's a massive win, not just for the bottom line, but for sustainability too.
Now this is incredible. First pass yield, that's the percentage of parts made perfectly on the first try, jumped from an okay 78% to an amazing 96%. That means way fewer reworks and a much more reliable process.
Now look at this. The non-productive time, the time spent just setting up the machine for a new job, was slashed from 45 minutes down to just 15. That is a 2/3 reduction, which frees up the machine to do what it's supposed to do, make parts.
And that same predictive power, it led to an 18% reduction in maintenance costs. The result is healthier, more reliable machines that are simply cheaper to run.
These results are already transforming the industry, but believe it or not, this is really just the beginning. The research is pushing even further into the future of intelligent manufacturing.
So, what's next on the horizon? We're talking about AI that actually understands the physics of machining. We're developing new techniques for ultra-hard materials like titanium alloys and composites. And we're expanding these smart methods to even more complex multi-axis machines. The innovation is definitely not slowing down.
So I think the ultimate takeaway here is this. We are fundamentally changing not just how we build things, but what we are capable of building in the first place. When our factories can learn, adapt, and optimize themselves, the complexity of what we can create becomes virtually limitless. It really leaves you wondering, doesn't it? What impossible things will we build tomorrow?